This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 52, an interview about technology and Ansys with Ansys CTO Prith Banerjee and VP and General Manager of the Design Business Unit, Mark Hindsbo. Welcome once again to our podcast. I'm recording this the day before I enter a turkey-induced coma from Thanksgiving, but you'll be listening to this probably after Thanksgiving, so I hope all of our listeners in the U.S. had a nice holiday and enjoyed the food, the family, and friends, as well as any other activities you had over the 4-day weekend. I hope everybody had a good time. This is a very special episode of the podcast, a little bit different. We're going to share an interview we did back in July. The original plan was to talk with 4 or 5 of the senior executives, VP and above type folks at Ansys. But because of scheduling and conflicts and such, we were only able to do this one discussion with the 2 people that were able to make the initial interview. And we never could really pull off the things with the other executives. They were all very eager. We kept on setting up times and we kept on canceling. So instead of waiting another 6 months, we thought we'd go ahead and just share what we have, which is still a very, very good discussion. Because it's a 45-minute talk that we had with the CTO and the VP of the design products. So why don't we take a listen and I'll let them explain what they do and we'll have a great discussion and we'll see you on the other side. Hi there. We're here talking today with a kind of a who's who of the people that run the various business units at Ansys Inc. And I want to thank all of you there in Pittsburgh for joining me today here in Phoenix. Hi, guys.
Hey, Eric.
How's it going?
Hello.
So there's quite a few of you there. So let's just start off by letting you guys go around the room and introduce yourselves and let us know your name, your title, what business unit you're responsible for, what your responsibility is at the company, because I know some of you are over the business units. And also, we always like to know how long you've been in the world of simulation.
Okay, well, let me begin. My name is Mark Hindsbo. I am the VP and General Manager of our Design Business Unit. The Design Business Unit is here to get simulation out in the hand of every single engineer, not just the analyst, although, of course, we love the analyst at Ansys, but we love simulation so much that we would like every engineer to benefit from it.
Right.
And we can talk more about that later. I've been with Ansys for about 4 years, and I have a broad software business background. I'm actually a nuclear physicist and wrote simulations in a whole different realm, more high-energy physics way back.
Well, I've always wanted a plasma simulation tool in Ansys, so in your spare time, if you want to dust that off and put it in there, it'd be really helpful for our semiconductor manufacturing customers.
Yeah, and maybe some of our aerospace people as well.
Yeah, starting to get into that plasma range. Okay, who's next?
So I am Prith Banerjee. I'm the Chief Technology Officer of Ansys, and I have joined the company about a year ago. Previously, I used to be CTO at ABB, Schneider Electric, and before that, I spent some time in academia. I worked in the area of simulation for more than 25 years. My role as CTO is to set the long-term technology strategy for Ansys. So to go beyond the current products that we have, what should we be working on in terms of newer technology, newer products, newer solutions, and services? That is my role.
Very cool. You get to do the fun stuff. Let me go ahead and ask my next question. Is really, and I just saw Mark a few days ago, so some of these are actually spawned by some of the conversations we had when I was there in Pittsburgh. But one of the things that I kind of came away with from my last trip out there was there's some of these big megatrends that we're seeing out there in simulation, like autonomous vehicles, electrification. What we see here at PADT is people trying to put more electronics in less space that generates more heat. What are you two guys focused on in terms of these kind of mega trends, and what is Ansys doing to help with those trends?
So let me begin, and I have Mark chime in. So you're absolutely right. We are working. We obviously, as you know, we have a whole set of products at Ansys around our mechanical products, fluids, electronics, and so on. But those are products. What we are working on is sort of solutions in front of our customers. So we are working on autonomous vehicle solutions, right? And so essentially, when you're looking at AV, you have to look at all this multiple sensors that you have, the camera, the LiDAR, and the radar and so on. And essentially, we're bringing in our products, our solutions from our optics business unit, our electronics business unit, and then putting it into what is called, we create scenario generation and so on. Then we are essentially putting out a complete vertical solution with our top customers. We just did an announcement with BMW to talk about Ansys AV solution in the autonomous vehicle space. Similarly, we are working on electrification. Now, many of our automotive customers are in the transition going from the internal combustion engine to the electric vehicle, right? So what is involved in electric vehicle, right? So essentially the electric motor is a change thing, right? So we have our Maxwell product, but trying to look at it, well, how will it actually drive electric vehicle? Then we have to talk about batteries, battery modeling, simulation, and so on. So we have a complete sort of vertical solution for electrification, and we are working with the likes of Volkswagen. We just announced a very exciting partnership with Volkswagen and with Cummins on our electrification solution. Moving beyond, we have identified sort of 5G as a big mega trend, right?
Yes.
We have companies like Ericsson and Nokia, they're all focused on 5G and everybody's excited about 5G. So we have a 5G set of solutions that we're working on, which is all about antenna designs and how do you place antennas and how do you do sort of PCB designs to support antennas and all the kind of stuff from electronics, semiconductor electronics and all the way around, right? Then in terms of other mega trends, I mean, people are talking about additive manufacturing, right? Big deal. So we have a solution for simulation to support additive manufacturing. Then we have a mega trend around sort of digital twins. Everybody talks about IoT and digital twins. And when I worked for ABB and Schneider Electric, we used to talk about sort of IoTizing all our products. So we have a fantastic physics-based simulation tool to drive digital twins across all industries. So those are a few of the mega trends that I'm focused on. And again, Mark is focused on another very, very big mega trend around Discovery Live, which I'm asking him to chip in.
Yeah, and I think there are the solutions that you and I spoke about, Eric, right? That I mean, we all see the same, right? Because we all participate in the same industry, and they're really driven by our end customers and their needs and how they can innovate their products. And they're all the ones that Prith mentioned, and maybe a couple more. And from a simulation perspective, the awesome thing is that these things have now become so complex that theoretically, maybe 20 years ago, you could go address some of these challenges without simulation, but you just can't today. The 5G and the density of cell towers and the latency rates and everything else, right? I don't know how you would solve that engineering challenges in a reasonable go-to-market without simulating the whole thing. You simulate it with autonomous, right? You have to drive billions of miles, and people have estimated that that's going to take us something like 8,000 years to do physically, right? And I don't think any of the car companies have an 8,000-year go-to-market plan, right? So you simply have to drive them virtually or simulate them virtually, and so on. So that drives our business. And then we have some other trends that might take, all of those are trends that take more simulation into classic product development, if you want, right? And then we have a couple other trends, like democratization, where we say, hey, how can we help every single engineer make as many decisions as humanly possible themselves as they're iterating, instead of having to round trip. It's almost like in the old days, right, where if you were in the accounting department, if you have to go ask the mainframe guy to run a program every time you have to have a new report, right? There's going to be less iterative insight. So that's one trend in simulation. And then you could argue digital twin is another one where it actually isn't the human being spawning the simulation anymore, but it's the machine spawning it on demand itself based on its sensor data and maybe an AI helping it. And then that will spawn a simulation to make a decision on maintenance or operations or so on, right? That's a whole, different trend in and of itself as well.
Cool. Yeah, I think the AI, we'll have to come back in a couple of years and talk about AI, because I think it's going to be a great discussion to have in simulation. But I want to go back to something that Prith said, and kind of, it was, sometimes we get so buried in these things that I forget the obvious. We really have made a shift from providing point solutions that the users had to cobble together to come up with a full solution, to really looking at that whole workflow and what are all the tools you need to solve a given vertical problem. And that really has been a shift in the last couple of years. It didn't really kind of dawn on me till you spelled it out there. So it's an important thing.
Platform effort that we are actually working. So from the CTO office, I'm driving sort of two initiatives, one around AI, ML, applied to simulation, and sort of platform, multi-physics platforms applied to simulation. And Eric, you just nailed it on the head. I mean, essentially, how do you take all these different point tools, right, and across this autonomous electrification, right? If you're a customer like an Ericsson or a customer like BMW, right, how do you actually take these 10 different tools and make it all work together through the right modern APIs, so you can call the right APIs from sort of application services, simulation services, and infrastructure services. That's how we are building our platform. But yeah, that's what I'm really excited about.
Yes.
But that's the technology that's going to drive these new solutions.
Right. And tying it back to what Mark was saying is there's a lot of stuff people are trying to do, our customers are trying to do, that they couldn't get there without simulation. So we need these tools. Yeah. We could talk about that forever, but let's move on. So one of the questions I get a lot from users, and you guys might be able to help answer it, is, how does your team decide really what you're going to work on in upcoming releases? What does that process look like? I think there's a lot of mystery out there on how a feature gets decided to go into a code, or a whole new code gets written.
Yeah, and I mean, it is a pretty big and important process, right? But I think it starts with one is, yes, there are a couple things that go into a single release, but I'd sort of back out and say, hey, we plan, multi-releases, even multi-years.
Right.
It starts, on one hand, it starts with all the trends we just talked about. So if we want to help our customers solve the autonomous challenge and be able to simulate 8 billion miles, what do we need to do, right? And maybe we need to add capabilities that we didn't have before. Or maybe we need to partner with someone, like in the autonomous. Someone needs to figure out how to create scenarios. It is not helpful that every time you need to create another, this is a 4-way intersection, and this is a 3-way intersection, and this is how they do it in Pittsburgh, and this is how you do it in Beijing, right? So to be able to simulate it, it has to start with someone has to create the scenarios, for instance, right? Which is something we've never thought about before. So you start on one end with, hey, here are these large opportunities for simulation to help product development, and what do we need to do to deliver value? And then on the other end of that, you have direct feedback from your customers in existing production that says, all of this is great, but I need feature X, right? Your multilinear plasticity model is not good enough in this instance, or you're lacking a set of materials, or whatever it could be, right? So you have, on one hand, you have very long-term strategic. On the other hand, you might sometimes have very short-term, very clear tactical needs. And then what we do is we go in. We're actually in the midst of kicking off that process. We start out really individual business unit by individual business unit. Planning. What do we think has to happen over the next 18 months or so? And back that into individual releases. And then once we've done that, we go into a planning process that is more cross-functional. So what dependencies do we have on each other? I might have planned on something, but it's dependent on someone else. And that also layers in, to your point, right, those cross scenarios. If we are to solve the autonomous scenario, and that includes mechanical, fluids, thermal, electromagnetic simulation, what are the cross things we need to put together? And then ultimately, once we've been through, both of those big vectors, right, individual BU narrowly thinking and cross BU company thinking, it ends up being a feature map for the next 3 releases or so.
So let me complement what Mark can talk about, right? So there's sort of 3 levels of of customer input that we get, right? So I, as a CTO of the company, I am routinely sort of involve myself in CTO to CTO level conversations, right? So I have sort of meetings with CTO at Ford, for example, right? Hey, Ken Washington, what are your challenges, right? John Lochner, CTO at GM, right? So we have those CTO to CTO level conversations in one-on-one meetings, in conferences, and so on. We were at the PADT show, talked to a lot of CTOs about what their needs are in the aerospace, automotive, whatever kind of space, right? That is one set of things that go in. Second thing is we have a customer advisory council. For example, we I mean, across BUs, we have many of the we put together about 20, 30 customers that come together, and collectively they provide input, right, to our leadership. But the most effective way that we bring in input requirements is from our large ACE organization. As you know, Eric, we have a very large, fantastic ACE organization. And those people, these ACE engineers, are working with customers throughout the world, right? So we have ACE people from North America, ACE people from Europe, ACE people from Asia. They come in, like, for example, last week we had the electronics business unit planning meeting, right? 4 days of planning meeting where these ACE leaders come in from around the world, right? And they say, from an ACE perspective, right, from North America, this is what we are seeing as requests for our HFSS product for EBU, okay? So, and they may say, rattle up these 10 features that they want, right? I want this, I want everybody want, right? So you take this list of things. Clearly, it's a resource issue, right? You cannot solve all of it. So you look for commonalities, right? What are people looking for? Oh, well, looking for this mega trend like 5G and so on. Oh, we really need to solve that 5G thing, how you position antennas and so on. So we put that into the thing, right? Or in the autonomous case, there is a feature for autonomous Doppler processing, ADP. Oh, we need to do that. Oh, we have this non-conformal mapping thing that we have to do for meshing. Oh, we need a tau meshing. So essentially, you have this long list of features that the ACE engineers and leadership brings together to our BU leaders. So, okay. And then, of course, we have to say, well, we have just 100 people, right? What can 100 people do in the next 18 months? So we prioritize and we come up with some plans. In these EBU planning meetings, we'll bring, as Mark was saying, the other leaders come in and say, oh, okay, you need this from a cross-BU perspective, from EBU to talk to our mechanical business unit because it's the multiphysics part that is needed. So this process just got started from last week. And now it will continue through October, right? And sort of a big planning meeting. And then in October, we say, okay, these are the resources we have in the company, and collectively, I'm sure you know that we spend about 200 million in R&D, about 1,500 R&D developers. So what are these 1,500 developers going to work on our product features, release 1, release 2, release 3 in 2020? That's sort of the overall scheme of things.
That's fantastic. I think there's a lot of people that wanted to know what that looked like. And the ACE input for a lot of our listeners is critical because that's where they interact. I mean, hopefully we have a few CTOs that listen, but I think that the majority of the users do have interaction with the support team. And the fact that that gets into the loop and is an important part of the setting what's needed is really critical. So lesson learned, if you want something, need something, don't just say, I need it or this doesn't work. Make sure you tell them why you need it and what the value is to you so they can get it back into the development team.
And the last thing you said, Eric, is super important, right? Because we get, as any product, software product organization, right, we get 1 million feature requests. So it becomes the art of how do you say no to 90% of them and which 10% are the right ones. So the more you can get it with a use case attached, right? The better it is for all of us. And by the way, the better the feature, becomes at the end, right?
Right. Yeah.
Because it could, physics is so wonderfully horizontal, but the way you apply maybe the high frequency analysis in the autonomous realm might be slightly different than you do it in the 5G realm. So you really need that use case attached so that we can make good product decisions.
Very good point. Yeah. So kind of along the lines of new stuff and new features, Ansys has partnered with folks, acquired folks, introduced new products, quite a few recently. My favorite, because of my background in mechanism design, is partnering on motion. So we're working with a South Korean company on a really cool tool that allows us to do very sophisticated rigid body dynamics type stuff, which I love. I'm an old Adams user, so having it built into Ansys is great. What's like for you two, what's your favorite new tool either acquired or written or partnered with?
Well, I would obviously be biased, so I would say organically, I feel like Discovery Live is my favorite tool.
It's the coolest. I'll say that.
It's definitely the coolest. But if I sort of take that off the table, I actually think that the Granta acquisition we did is pretty spectacular, and it's spectacular because it'll help all of us. Right? There's so much material knowledge, and really good simulations require, very good material knowledge. And then as you look at the sort of, early prototype development, where you also have to think about other things than just, what's my young modules or what's my viscosity and so on, right? You also have to think about things like sustainability, price, manufacturability, and so on, right? Granta really has a wealth of knowledge that I think we've only scratched this, or I know that we have only scratched the surface of how it's going to make things better across the entire board for all of us.
Yeah, we're gonna focus on
a few things from my perspective.
Yeah, go ahead, please.
As the CEO of the company, right? So, I mean, when you look at our users, right, and they are using simulation, and so what are they looking in simulation in terms of improving the quality of simulation? They want to improve run times, right? I mean, some of our things take like 1,000 hours to run, and obviously we would like to speed things up. So anything that we do to speed things up is of value. Mm-hmm. They are looking at the accuracy. You can speed things up if you are willing to give up on the accuracy, right? Mm-hmm. And so we need to work on the accuracy and runtime trade-off. Then we have to look at the stability, the reliability of this thing. Does it work all the time, right? I mean, maybe it runs sort of 90% of the time, but 10% of the time these things just croak, right? So, I mean, we try to do meshing and it didn't do the meshing and then it's kind of fails, right? And the final thing is the ease of use, right? So essentially across our tools, we have put in a lot of fantastic features in terms of, for example, mosaic meshing that came out in our Fluent tool, right? Mm-hmm. Fantastic technology which enables us to do more things much faster. With mosaic meshing, the speed goes up to the roof, right? Mm-hmm. Same thing with our tau meshing that we announced, EBU product, right? I mean, there were things that did not work in those most complicated antenna designs, right, or cell phones. And now it does work, right? So essentially, it's addressing the robustness issue. So these are some product features that we are very excited about in terms of cool technologies like tau meshing, mosaic meshing, mm-hmm. that enables things. With respect to runtimes, right, we have always had the issue, right? We run our things on our workstation, right? And then if you want to move things up, you have to move to high performance computing, HPC. Mm-hmm. But you look at HPC, how many people can afford to buy a Cray machine, right? You cannot. Right. So therefore, you have to think about going to the cloud, right? Once you go to Amazon or Microsoft Azure, you have like 10 million cores, if you could afford, right? You could run it on those. So our Fluent tools runs in a very scalable way on 200,000 cores on a Cray machine. So always we have thought about, can we go to the cloud, right? Mm-hmm. And of course, we have in the past worked with our cloud hosting partners like Rescale and Imbix and so on. Mm-hmm. But this last June, right, in R2 release, we had this Ansys Cloud, which is a cloud native solution. I'm very excited about it, right? From the desktop, you want to do cloud bursting, you want to go to the on-prem data center, you could do it. You could go all the way to the Microsoft Azure cloud, you could do that. And doing that in a very interesting way, tied with some of the newer business models that we have got around Ansys elastic units and so on that I'm sure you have seen. I think the future is all around the cloud, right? People will do CAD design on the cloud, they do simulation on the cloud, collaboration on the cloud. So there's a cloud piece and there's a platform piece that we are working on to allow for PLM, et cetera, et cetera. SPDM is technology called simulation process data management on the cloud. These are really, really good because it's less about running a particular simulation faster. It's about the whole workflow. Can I improve the overall workflow? And that will be done through the cloud, through the platforms, the stuff that I'm talking about. These are things that I am personally very excited about.
Yeah, I'm glad you brought it up. I think it's going to change the way we do our job and make us more efficient. It's going to be a big shift when all that's up and working. Being able to solve in the cloud is pretty exciting. Yeah.
Think about how our productivity tools, like when I had a Word document, I send it to you, Eric, for edit. Mm-hmm. Then you send it to Mark, right? They're all emailing our Word files together. With Google Docs, we can simultaneously edit the file, right? It's so much easier, right? I'm doing editing from my cell phone, iPad, workstation, etc. The same thing is going to happen in the CAD and simulation world. And we just have to be prepared for it.
Yep. Be ready for it and have the right solution. That's so true. So one of the things we talk about at Ansys is really as a goal, especially as we've kind of made the transitions with new CEO over the last couple of years, is this idea of really making pervasive simulation a reality. So that's getting tools into the hands of more engineers so that more people can drive designs with simulation. So this is more of a philosophical question, really, but what challenges do you see in spreading, not necessarily we have to write more code, but what organizational challenges or process challenges do you see in spreading simulation deeper and wider in various industries?
I think Eric, and you and I have talked a lot about this, right? If you look at all technology that has become pervasive, it's become pervasive for two reasons, probably mainly. One, you got to an ease of use where a much broader set of population could use it, right? That was true for the GUI on the PC and so on. And you also get to a certain speed, right? If we sort of go back to Gutenberg's printing press. That was not easier to use than writing, but it didn't take a monk a full year to write a book, right? You could do a copy in a couple of seconds. And it was true to a certain extent. You could argue for the internet back in the day where all of us had to do dial-up modems, and it took us 25 minutes just to get connected. You wouldn't check the weather or your stock quote, right? Because investing 25 minutes in that process made no sense. Right? So you have to get technology to a place where it's reasonably interactive, and where it's reasonably ease of use. And then in terms of cultural on both sides, you also have to let go of certain things. And what on the inside, like we are proud rocket scientists, right? In the broadest sense at Ansys, but that doesn't mean that we have to surface every knob and dial to the end user, right? Right. And sort of, hey, look at how smart we are, right? Here are all the things you could go tweak. That's culturally not helpful. I a lot of times with my team use Google search, given that Prith brought up Google as an example. Being able to query the entire web in 100 milliseconds and serve up a result. I think all of us can inherently look at that and say, man, what a set of database query AI technology must that require? But the user interface is a simple text box, right? Where it's not an SQL query where I do some Boolean logic and choose database fields, right? In which case Google searches have gone nowhere. So part of us is taking the stuff that we're most proud of, right? The simulation technology, and to a certain extent hiding it. You should not know. Depending on Reynolds number or whatever it is, which turbulence model to use. Right. It should just be slotted in on demand. You should not know which meshing algorithm. Not the normal engineer should not know that, right? Necessarily. You should be a good engineer, know about material properties and so on. But the fact that double points have some error that we're doing, right numerical corrections on the backside should just be hidden. And that's probably internally Ansys one of the biggest cultural things, because we're so, in a good way, proud of the stuff that we're doing, and we love to be geeks. But one of the things we just shipped, for instance, in the new Discovery Live is thermal stress. Right. Everyone who's been in simulation for a while knows that that's multiple solvers being coupled to each other, but the setup is just thermal stress, right? It's hey, I want to do a thermal stress analysis. Fine, give me some kind of temperature or heat input, and give me some structural boundary condition, and we're done. Right. So that's one, and then of course on the customer side, there's an equal cultural change that has to happen. Because processes will change. One of the things I preached recently and that got people's eyebrows to pop up a little bit, I preached what I've provocatively called careless engineering.
Okay, that makes the hair stand up on the back
exactly,
of my neck.
That does make, and that's sort of deliberate, because in no ways would I want people to be careless, and all of a sudden we have products that explode in the faces of our users, right? But because a lot of things have historically been expensive, physical testing is super expensive, right? It costs millions of dollars to do a jet engine.
Right.
A failed simulation run on 10,000 cores that ran all weekend and tied up my supercomputing cluster is expensive. So we've taught our engineers not to ask too many what-if questions, right? Come to me with a almost final spec, and I will verify that it's correct. That is not how innovation is done, right? Dyson did 5,500 prototypes over 10 years to change the vacuum cleaner, right? Penicillin was done by an accident because all of a sudden there was one of the Petri dishes, right, that behaved differently, but it was by accident. We need to be more careless, right? We need to have more accidents up front. And experimentation now can be extremely cheap where we're going. You can ask 5,000 what-if questions in an afternoon. And the cost of making a mistake is an undo button. But we're mentally not quite wired that way because we've been so disciplined in a lot of those mistakes being so inherently costly. But you actually want to make them upfront in your design process. And then, of course, don't be careless at the end of your design process.
I wrote down a note. I want to come back and talk to you about that in the future. I think that's a really good topic to really delve into. It makes me very uncomfortable, which usually means it's a good topic. Good. What about you, Prith? What do you see barriers out there?
Most of the things. I mean, since we are out of time, I will not go about this. In general, it is along the message of making simulation easy to use, and the platform technology I was talking about, right? Today, our engineers spend so much time in making sure our HFSS tool, here is how you write this Python script to write the file into the sort of Ansys mechanical or that into the workbench and so on. And the engineers are spending their time on the actual submitting of the jobs and so on and so forth. And they just get the scripts together to kind of work. And then we have a new release and things don't work anymore, right? So imagine a situation where through a true modern set of APIs and modern set of platforms, the tool flow becomes so easy to use. So the engineers can really focus on the engineering problems at hand, right? As Mark was saying, when Dyson engineers are trying to do the vacuum cleaner, right? They have to do 50,000 different versions of it. Imagine that the tool flow said, here is the vacuum cleaner thing, right? And you set up through some automatic parameterization process, right? I'm going to make the vacuum stronger, right? And there are 20 different sort of horsepowers of the pump that automatically get generated, right? I don't have to physically enter those things, right? It just comes in, right? You tell the design tool in English, right? I want thermal stress of this over 5,000 variations, right? And it automatically sets these things up, and the engineer focuses on the engineering problem, not on how these tools are connected together. Not all those, which is, so we want to make it easy for the engineer, right? I mean, way back when, we used to know how to solve integrations and calculations, right? We learned this in math school. Now using Mathematica, you can just type in the stuff, out comes the stuff, right? So I, as a scientist, can focus on the integration, not on actual formula doing the integration, right? I mean, when we are in sort of high school, we learned how to multiply. Now you can type it in the calculator, right? Mm-hmm. So easier. So that's the whole point, right?
Very good point.
Can I make this a much easier user interface, as Mark was talking about, and make the job of engineers so much easier? Because today what happens is, among the 100 engineers in a company, only 2% of the engineers are really using the simulation tools. 98% people are using MATLAB, Simulink. Why? Because it's easy to use. Mm-hmm. We want our tools to be as easy as MATLAB.
Cool. And we are seeing that. I think it's very obvious that every release we get closer to that. Even to the point of like changing on the mechanical side, updating the user interface to a more modern ribbon has been, I love it. It's fantastic. And it does make it more usable for more people, little things like that. So we are running out a little bit of time. So I got two more questions for you guys. The first one is when I interview users, I always ask them, hey, Ansys developers may be listening. Do you want to send them a message? Well, hey, people who are in charge of Ansys development over there, there's users listening. What message do you want to share with the users out there?
So this is kind of what I talked about in terms of the process, right? And there's 3 levels of feedback that we get at the CTO to CTO level. So if you're an engineer, right, make sure that your request or whatever is making it to the sort of CTO at Ford, so that the CTO at Ford, when I talk to him, he will say, hey, we really want you to work on model-based systems engineering or moving to the cloud or whatever. That's the highest level. Second highest level is make sure that when your company is invited to the customer advisory boards, you kind of show up or make sure that whoever is representing your company and that advisory board shows up. But those are really hard things to do as an engineer. What I would do is, as we just talked about, right? Our engineers are working day to day with the ACE engineers. And if you don't like a feature, you want this sort of tau meshing kind of a feature to support a non-conformal mapping, make sure that is known, right? And if enough engineers scream for a feature, it will show up in their priorities, right? If 10 people across the world, not only in North America, not only just Phoenix, right? But 10 customers around the world are screaming for a feature, it will happen, right? If everybody wanted the cloud, we will push it to the cloud. If nobody wants the cloud, we will not push the cloud.
Good point.
So that's sort of the point. Make sure your input is going to the ACE engineer that is working with you day to day.
Yeah, don't assume someone else has submitted it. They may have, but getting the multiple submissions really helps you guys see the strength of the need. That's a really good point. Yeah. How about you, Mark? Anything you want to share? Our users to know?
I think, Prith, I mean, certainly in terms of getting feedback to us, work with our, like you, Eric, right, with the partners that we have, or with our own ACE organization, and get us the input. Like the reason why we were together the last couple of weeks was because we had a channel advisor council. So I just add that equally to our own ACE organization, the fact that we have, Eric, it's very hard for me to distinguish between the fact that you have your own company and that you're part of Ansys, right? Because the feedback flows very well, right? And if a set of our most trusted partners say, hey, listen, we have a set of users that really needs this, it gets bumped up in priorities for sure, right?
Yeah, definitely. So my last question is kind of out there, and get out your crystal ball, right? And we've got some tech on the drawing board like AI and machine learning that we know we're going to be playing with and finding a place for. But let's go even further out there. What excites you that's out there that's not even on the drawing board yet that you think will be mainstream in 5, 10, 15 years?
Actually, I would like to point out on AI/ML. I mean, we are just scratching the surface of it.
Okay.
So I will just tell you what the opportunity is, right?
Yeah.
So when we typically solve a mechanical solution, right, or electromagnetic simulation on HFSS, right, you take a large thing and we compute the electromagnetic field, electrical fields and magnetic fields, right? We go back to Maxwell's equations, solve it numerically using finite element methods, finite volume methods, etc., right? And it takes a lot of time to do this, right? Now, when you do this and you're trying to design an antenna, and there is a slight modification of design of antenna, and you run the whole thing again that takes 1,000 hours. Then you change the design a little bit, and you run it again, and it runs it again 1,000 hours, right? So with AI machine learning, there are a few sort of things that we think will be highly disruptive. One is just the user flow. These tools are, as you know, as I'm sure you've used the tools, right? Very difficult to use. It's sort of for the high-end, sort of the nuclear physicist that Mark was, right, when he was in Europe, right? But I mean, those PhD people know how to use the tool. They know how finite element methods work, how the meshing should work. Should I use rectangular meshing, triangular meshing, tetrahedral meshing, this, that, etc., convergence, and boom, it runs, right? So these tools, you can have AI machine learning watching what the high-end user is doing and then sort of learn with time. And pretty soon, you will submit a job like, you will say it in English, do the thermal stress analysis or do the wing design for a Boeing 737 MAX plane, and it will set up all the fluent settings to simulate the lift on the fluent tool, right? That's out there. Second thing, and that's what we call is the general area of customer productivity. Second thing, very, very big area is, can AI speed up simulation? And we have a hypothesis that it does.
Good.
So Imagine you are setting up HFS as what's a very small geometric primitives like a sphere, a rectangle, a triangle, or whatever, and you throw it a sphere and it does the EM simulation. Then you throw it a rectangle, it does the simulation. Pretty soon you give it a new structure and it can, without doing a simulation, you can guess what the output should be. This is right. That's quite completely crazy. And we have shown some early results where the runtime of simulation can go from 10 days to 1 hour, right?
Wow.
Massive things. But these are out there in the future years, right? In the 5 to 10 year period. These are the kinds of things that you will see. Now, ultimately, in 10 years, what is going to happen is when you're trying to deploy a 5G system, it is not just a 5G antenna, which today we are working with our companies like Ericsson on, but people like Verizon or AT&T, they are going to deploy 5G across the world or 5G across the US, right? I mean, to simulate those things at a city level, the city of Pittsburgh, city of Phoenix, right, requires massive system level simulation. But system level simulation, you can do it with MATLAB, but you lose the accuracy. So the beautiful thing is using reduced order models, can I take the really accurate simulation of HFSS and extract it, abstract it, but instead of running it 10,000 hours, it'll run in a second. Then it string 1,000 of those things, 1,000 antennas in a city of Phoenix, and the whole thing runs at a system level accurately with reduced order models. That's the system level vision that we are thinking about, we are imagining, and I think it will come in the next 10 years.
I hope so. I'm excited about the system level across physics is very exciting, very, very exciting. How about you, Mark? What's your crystal ball say?
I think you need to change, for me, the premise of your question.
Okay, go ahead.
And what I mean is because you say, what is not even on the drawing board that will be mainstream in 5 to 10? Okay. I think every single thing that will be mainstream in 5 to 10 years we have on the drawing board today.
Good point.
Right?
Good point.
Whether that's sort of AI changing it or it's IoT where the device itself can reconfigure itself because sensor data has changed or whatever it is, right? So you could either say, hey, listen, what do you have on the drawing board today? That would be mainstream.
Well, I don't want you to give away anything proprietary.
No, but I think Prith answered that well. It's not proprietary, right? I do think AI will have a profound impact on simulation. I don't think it will displace simulation because stuff you can put in an equation, it's much, much better solved by you spend 10,000 hours, training an AI in something that the solver can solve in 15 seconds. That's stupid, right? But on the flip side, figuring out what is the right configuration, as Prith said, right, to optimally set this up or making a fuzzy logic decision on something or understanding design intent or something like that are stuff that AIs will be more. So once you couple predictive simulation with more higher level decision making in AIs, I think you get some very, very interesting scenarios as sort of one of the areas that we're working on and investing in. I think things like additive manufacturing that we've been talking about, right? It's not mainstream today, right? It is not. And it will take 5 to 10 years before it becomes mainstream, right? When will we have FDA approval or FAA approval for using additive manufacturing in a plane or in a stint or whatnot, right? Those things just take time. Right. And then you can speculate beyond 5 to 10 years and you can come up in the realm of sort of insanity, right? Nanobots and biological systems and so on, right?
Actually, on the topic of 10 years out there, I think it's what Mark just mentioned, triggered a thought, right? We today focus on sort of the physics world of simulation. We simulate mechanics, fluids, electromagnetic, and so on. What we do not simulate today well is biological systems, right? Right. You look at the pharma industry. I mean, in the US alone, they're spending like $160, $170 billion, right? As to get a new drug, it costs a drug company like Pfizer $2 billion to come up with a new drug, right? With all the trials and certification and so on. And this is what used to happen in the aircraft industry, right? You had to build a wind tunnel to test a plane that will actually fly. Well, you don't build wind tunnels anymore, right? Because people are now comfortable with the simulation, and that's it. They will just build the airplane based on the simulation, right? A world will come at which point you will be able to simulate biological system with the chemistry, right? I mean, this drug, right, will have this chemical reaction with my cell structure within the body, right? And it will so accurately predict the interaction right? It will, so as on this petri dish that kind of Mark was mentioning, sort of invent penicillin, right? These will be done through simulations, right? Now,
Cool.
The pharma industry is not as advanced as the automotive industry. The automotive industry went through sort of the Autodesk and CAD and all the simulation models, and now every car is built through a CAD-CAM system. Similarly, we believe that the drug industry, the whole biological industry will be in this area. And now, this is not to say we are going to move into healthcare. I'm just saying, giving an area of the general area, right?
Someone's going to do it.
And it's also going to be more multi-physics. And what do I mean like that, right? Today, we can 3D print a heart out of cells, right? And you can use mechanical to say, hey, what should the initial structure look like, right? But then as soon as biology takes over and the heart starts growing, those processes actually supersede anything we can calculate in mechanical, right? Because the cell division is more important to how it develops than the structural integrity of each and every cell. So you almost have to combine the two to get, if you want to go into areas like that, right, where you're 3D printing biological spare parts for all of us, that's a whole, it will give multi-physics a whole new meaning.
Right. Yeah. Wow, that's a great one. I love that. But so there'll be a bio business unit at some point at Ansys.
Maybe.
Let's hope so.
That was again back to now you have to reformate the question, because that is, what do you not even have on the drawing board that
exactly.
might speculatively be 20 years out there somewhere.
Well, if you're like me, organic chemistry was always an area. One of the reasons why I'm a mechanical engineer is because I just couldn't get it. So that may be a different group of people to come up with that. I've taken more time than you have promised me. I really, really appreciate it. Any parting thoughts with our listeners before I let you go?
Well, thanks at least for me for the opportunity, Eric, and for the partnership.
Thank you very much. Talk to you later. Yes, I am late for my next meeting. So
okay. Thank you guys so much for your time, and hopefully we'll meet again and do this again. We'll learn more. It's always fun, and it always goes longer than we thought because it's so good to talk about this stuff. So thank you much, guys. Have a good rest of the day.
So thank you very much for joining us on this talk. I think you realize it's a really good look at how smart and capable the people who lead Ansys are. These are just two of several, and how much they get simulation and product development. They it's become a large company, but they still are in touch with what the users want and need. You also noticed in the introduction, I got a little embarrassed because I was expecting more executives. And like I said before we started the interview, we will try and make that up in 2020. We'll see what happens. See if we can get more people on. I think it was a great discussion, and if nothing else, I'd love to follow up with those two. As mentioned in the last podcast, we don't have a commercial. We're kind of, our commercials have gotten old and stale, and we're working on getting more professional options, including some outside sponsors. So in lieu of a commercial, I just want to send out a reminder to please consider PADT as your Ansys partner if you're in the southwestern U.S., including all of California. So we do it from Texas to California, and if you're in that area, we'd love to be your Ansys rep. Also, please think of us as a provider for your 3D printing services, any scanning needs, optical scanning, any product design, and of course, simulation training, customization, and consulting services across all the physics that Ansys represents. We're here to help. We're an 85-person company that loves to do cool engineering, and please do reach out. We'd love to work with you. The only news I want to report on very briefly, because that interview did go long, is the stock. It is the day before Thanksgiving, November 27th, around noon, Phoenix time. The price of the Ansys stock is something to be thankful for. Yesterday, it hit an all-time high of $255.18 a share, and it bumped around $254 around noon. I haven't checked to see what it is later in the day and what it's going to be after the market closes, but it's a good way to hit into the holidays with an all-time high for the Ansys stock price. And on the next episode, we'll look back a little bit more, and then in January, we'll look at the year. I'm going to skip the rest of the news. I'm not going to mention any blogs or any other things. I've just got 2 events to remind folks of. For those of you who are here in Arizona, especially if you're down in Tucson, our annual customer appreciation event is December 18th at the same place we usually do it. Do check out our website and the events page to learn more, and you've probably been emailed about it as well. But we'd love to see you there if you're a Tucson customer of PADT or any way affiliated with PADT. Even if you just listen to the podcast, come on out to our customer appreciation event. And our last webinar of the year is on December 4th. And we are covering a new product called MotorCAD. It's a third-party product that is being tightly integrated into Ansys, and it is a tool for designing electric motors. Very cool. We love it here. Please do check out the webinar to learn more about it. And I want to thank everybody for listening to the podcast. Don't forget to subscribe at www.padtinc.com/opt-in. Spread the word with as many people as you can. We'd love to get more subscribers, and never, ever hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 52. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employer. For more information, visit www.padtinc.com/blog. And please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.